I'm gonna try it. Hello. Meow. uh, uh. Righty. I hope you're all energized back from coffee break. We now have our next talk, WebSocket 101 in Python by Judy. Please welcome. Thank you for coming. So I hope you guys didn't fall asleep. I will try my best to keep you guys awake. So this is a WebSocket 101 in Python. I mean, if you don't know, 101 is actually kind of in university code. It's kind of basic course, but in the topic later on in this talk is we might expose into some advanced stuff. So that's to tell you in advance. My name is Judy. I'm actually coming from Toronto. That's a city where I work right now. It's actually wonderful. By the way, that photo is actually it's actually after I actually had to fight with the whole bunch of bugs. That's not fun at all. So what is on the menu? So we're gonna discuss talk about what is a WebSocket. Why do we even care to implement this in Python? And we're gonna see some demonstration. I'm gonna go step by step in the demonstration. And if we happen to have time, you have chance to see how it works with the RabbitMQ. Hopefully, a lot of people kind of have heard about this one or ever use it. And we're gonna talk about the alternatives later on. So let's start with the WebSocket. By the way, that's a real thing. It's not Photoshop. And yes, I don't know what it is either. And so WebSocket, 9 character, is it's a protocol that provides full duplex communication channels between process or machine. I mean, if you know, process didn't share the memory between to each other, so it's technically similar to when you kind of split into different machine, which is actually kind of this is actually allow the real-time communication between the client and the server, which I hope that a lot of you guys are the game developers, so this is actually really useful. The next one is actually sorry, that's too forward. So it's designed for web development, and I just spoiled the fun that it's utilized the HTTP for the handshake process, which I will show you what happened during the handshake process. I sure you like it. And back when a few years ago, it's actually kind of troublesome to work with the WebSocket, but now it's actually being standardized as the IFC 6455 in 2011. I'm sorry, it's actually a lot of character. And since it's standardized as the IFC specification, so it's now support in all modern browser, finally, including IE10. If you're kind of surprised that Microsoft decided to like, hey, let's follow the standard. This is a general kind of the structure of the WebSocket, the application of WebSocket. So you might have the HTTP that serves a lot of stuff, including maybe like REST API and the whole bunch of stuff that you need or you might not need, but you have it anywhere. And there's a WebSocket that could be on the same server or on a different server. Oh, nice. I love lighting. By the way, don't fall asleep, guy. So why do we want to like develop a WebSocket server in Python? Which is actually a good question. We have like a Node.js, which is actually have like a wonderful library like WebSocket.io, which is easy. But so that's one reason. There are a lot of like third-party library available and the measure. In another word, it's actually not buggy. Like last year, I actually developed the chat server at my company, and to tell you the truth, I have to hunt down the bugs in the Node. I think it's in one of the Node modules called like Node AMQP. I never want to read that code again. It's actually hard to track, and also not very well designed. And also, it's easily integrated with the homegrown modules, which is mean that, for example, you have the API that you have like REST API, you have the whole bunch of stuff, but I'm pretty sure that nobody actually allowed the public access to those APIs. So you can have some kind of like ACL, all the crazy stuff that gonna lock down and gonna make life of the developer harder. If you use Python, well, since you're gonna implement the security stuff in, for example, security. So you implement this stuff in Python. So since if you're gonna develop something in Python, like WebSocket server in Python, so you can reuse what you already have developed for something else in with the WebSocket, which I did that before, and it's actually kind of save a lot of time. And the next reason is simplify the deployment. I'm also the release engineer, and I have to say that when it seems to be okay to have like, okay, we have this server run in, for example, for the WebSocket stuff, okay, Node.js, Python, and sometimes you have PHP, Java, Ruby, whatever it is. And if you are the release engineer, you will know that once there's something wrong with some technology stack, is the pain in the butt. You actually, for example, if you had actually lost the JavaScript guy and like he on vacation, you have to track down, is a nightmare. If the Node.js decided to like upgrade and then break the other library, you also have to like the open source guy. They never sleep. The guy I know actually only sleep 2 hours a day, but they don't have time to fix all the bugs. So you're gonna have to help them fix it. That's take times. So. And besides, you have to like split into multiple packages. You have like multiple procedure to ship. In our case, where this demo we use a Tornado framework, it's actually have the built-in HTTP server and the WebSocket. So you can deploy as one single application to the server, which is actually pretty. You're gonna make like the release engineer a lot happier. They're gonna be your best friend in no time. And the last one is the since well, it's not a socket IO, so there are not like many magic stuff that going on. So you're gonna have to implement a lot of stuff, but it's not like you're gonna have to go all the way down to the hexadecimal and try to like send the bytecode and deal with the socket. You just kind of got to somehow deal with the only with the message, which is okay. So in that case, you actually kind of have, well, sorry, it's a typo there, not really full control, but almost full control of how it works, and you can easily integrate it into the other component and services, which is, that's maybe one reason I'm actually never look into the Node.js for the WebSocket. So so now we're gonna move on to the demo. And so in this demo, we are using a lot of technology. I would simply say I would not mention anything about the front end because it's boring. I mean anything that related to jQuery because you guys probably know about it. So this is what we are going to use. So I have, for the HTTP side, the boring part is I have Flag, which is, hopefully you guys know about it. If you come to PyCon JP 2 years ago, the guy who wrote that also here, and he had gave a lot of talk about it. I think I use the Flag box. That's a new layout. I'm not gonna mention that too, but you should Google for it. SCSS jQuery and vanilla JavaScript. That's a pure JavaScript, by the way. Just so you know, I will show a little bit about that. On the WebSocket side, I use the Tornado framework. That's what I kind of almost use like every day after working hours. Pika, which is the AMQP library, and the RabbitMQ, which is provide the advanced message queue protocol, which I will tell you what the benefit of using that later in this talk. And now it's time to see this in action. But by the way, since we don't have much time, we only have half an hour. So you are free to check out the code if you have a computer, which I'm sure half of the room actually have, except you can do that on the mobile phone. It's on GitHub. If you are the Bitbucket fan, I'm sorry. I don't have time to mirror the code to different repository. Ready? I'm sorry, but the URL is long too, not just, it's really ridiculously long. Okay, ready? Okay, so one guy kind of not give the birthing. By the way, this is just a warning. Just 2 days ago, I just tried to set up the demos server, which is now offline thanks to my ISP. So I just found a bug, and this, if you are using Linux, I'm sorry. If you're using Mac, you're good to go. Although if you run Linux on Mac, I'm sorry too. There's a problem with the Python 2.7.6 that kind of is creating a bug in the Pika library, which is kind of at the end of the. We're kind of going to use that at the end of the talk. So if you follow it, we can use as much like 75% of the demo, but I will tell you when the bug is coming up. And in that repository, we have the step 0, 1, 2, 3, which is that's the step that we are going to follow. So so the first one is a mock-up. So if some of you actually come here earlier, you already see the spoiler already. So let's look at it. So this is kind of like the application. So I'm not going to show you the whole detail, but you see that there's the login name, there's a screen name, there's the which you can type, which is anything. Just try to be polite. And there's a message here, a message box here, and there's a body list. This is kind of the design. That's if you check out the step 0 and you run the Python in the HTTP folder, you run Python server.py. That's what you see when at the root level. Oh, sorry. So come back here. I forgot this. Sorry. So now the step 1. So now we try to do the basic integration, but I have to tell you, nothing is work except it's actually connected to WebSocket. But how would that work is this is how we lay out. Sorry for the color. So in step 0, you only have the Flag application, which is just provide the HTTP. In the in step 1, now we actually add the Tornado app here, which is only provide the WebSocket protocol. And I hope I have a remote. So what is about to happen is, first of all, when we load the page, is we do the handshake. That's kind of like how it looks like in most of when people think about it. But in reality, that's what happened. So in JavaScript, this is from the pure JavaScript. So you have a WebSocket here. You actually specify the URL. By the way, if you read the book and it's actually keeps mention about the HTTP, just forget about it. they kind of kill that HTTP protocol in when you try to connect to the WebSocket. And this is a namespace. This can be anything. You can even put the port 80 and it still works. And so in JavaScript, it would look like that, and it would translate into the raw HTTP connection. And so back to the server. That's how that's what you get, the HTTP 101, and now the browser will switch to the web socket protocol. And in this step, at this step, the JavaScript can only send a message, and the server will just reply whatever it's got. So sorry, the text is too small, and so now we're gonna see the demo. So let me see. So we are going to check out the. I'm gonna put down the microphone just 1 second. Wonderful. Okay, we got a lost connection. Anyway, it's lived for too long anyway, so let's try. So now you got the ugly user interface, and the web inspector designed to open on the different windows. Wonderful. Here we go. So now I kind of set up the global variable here. So if so I would just say like send hi there, or if you're British, you'll be greeting, French bonjour, and something else. So you see that the it seems that my Mac today is actually refused to work in the way I want it to work. So here you will see that I'm actually send a message, and the server just say this is unprocessed data, and the Python will say, hey, you say hi there. In the code, which I would try. I mean, I would encourage you to read it. But tell you the truth is because I'm not going to show all of them because it would take too much time, and I only have half an hour. So you will see this that this is actually kind of like based on the example that you get from the Tornado framework. Read about, and you will see that this one just say, hey, write a message, and then say you say something, and that's just the basic stuff for this stage. But at least it's guaranteed that now we actually connect to the WebSocket. And now we are going to move on to the step 2, which now we're actually gonna start let people talking. And as I mentioned earlier, my demo server was down thanks to the Canadian IPS. So we are going to go without letting anyone talking to each other in this session. So the feature of the demo app is no registration, right? So it is wonderful. It looks like an IRC, except not using IRC protocol. The identity must be unique, which this is actually for so that we can we guarantee that it's broadcast to the right person. You don't want to receive the message, you know, when you don't want to send a message to somebody who you don't want to send to. But by the way, IRC is actually everyone see the message, so kind of useless. So that's the diagram on how the identification process, which is I will post this online this slide online later, but just in a nutshell, when somebody does log in, it's the server will say, hey, are you unique? and say yes, okay, send back to the user and say, okay, now you're now identified, and the server side we actually send to all the socket, send the message to all the socket except itself. Say, now this guy just came in, welcome him, not you know. And it's the same thing with when somebody actually leaves the room, which is we detect this when the socket is open or closed. Yeah. So sorry, just correct it. Is that identification is something that is through the message, but the when the user leaves, it's actually rely on the on close event, and that's how the message is being sent. Is like I mentioned about the broadcasting. So the sender send a message, and this guy and the socket connection for the sender will broadcast a message to everyone else. That's how it works. And the difference between these two steps is actually quite a lot. But one thing that is significant is actually the communication. Previously, when we just started, when we just start basic integration, it's using raw string. It's doing nothing. Now it's actually changed to the JSON RPC, but it's a simple one, not like the crazy one from the XML RPC. And the Tornado app, which previously just doing nothing, now it's actually have ability to broadcast a message to the other client, which please remind me to actually show you that code too. So is the WebSocket broken? Nope. Wonderful. But I'm gonna kill it anyway. So now, hopefully, if we didn't run into the bad file descriptor, it should be working. So now we got to Windows. So first of all, I would say, well, use my handle name. So I got this guy here. And now when Mr. Ghost coming in, you see that as soon as Mr. Ghost actually identify himself, it's actually pop up on the another screen, and now they both know each other. If now as myself, I actually say hi there, and Mr. Ghost will say back off. Duplicate username, try again. Whoa, interesting. Why is that? Oh, okay, fine. Hi there. Okay, sorry. It's probably like the hidden form that I didn't return the focus. So you see, this is how it works. This is kind of really basic. It's actually just like kind of in the code, which again I encourage you to read. Basically, the difference from the previous step is this guy is a static property that keep tracking on all the socket connection. The message that being sent from the client is an RPC. It's a JSON, sorry, and it's maintain. It's also contain the method, which is actually tell which one to what to do. This is kind of identification. And as you can see, when I say, hey, okay, somebody sent a message, cool. So I broadcast right away, and I loop through all the buddies and send him the content. You will see this guy here, but if we have more time, if we can go through the next one, is this guy will gone. Okay, so we don't have much time, so sorry. We're gonna get through faster, fast and furious. So the next step is now we work with the RabbitMQ. Have anyone missed Pika? By the way, Google for it. It's cute. I don't have a picture. So Pika. So now we're gonna use a Pika, which is actually mean we're gonna use RabbitMQ this time. The demo application, however, we decided to use the one blocking connection. is the it's actually not suitable for Tornado framework, but we're going to use this anyway. And we use one durable fan-out exchange. This is mean that if I have a queue that binds to that exchange is kind of like some kind of like the channel that you can talk to. You can send a message. Just read the documentation. It's wonderful. It's a wonderful tool that you should be using. And once you send to this guy, which is a fan-out, which is mean when I send to message to this exchange, it's distributed to all the queue that bind to this one, to this exchange. And each socket connection have its own temporary queue. It's only one. It's being queued instantly after the socket connection is off. And now it's actually changed. The way that the message exchange is also changed. Now we use a RabbitMQ to do all the broadcasting, and the application, which actually the single thread, because that's how the Tornado framework works. Now it's actually asynchronous. It's actually become multi-thread because it's a blocking connection. If we keep it there, it's actually going to block the event loop of the Tornado framework. So we have to spawn a new thread for the consumer and for the publisher, and that's why now it's become multi-threading. And as I mentioned earlier, not really mentioned earlier. So the disadvantage of this, the bad news is the nature of multi-threading is kind of lead to the complexity and potential bugs, but it's scalable. You can deploy multiple instance of the WebSocket server, but when you try to broadcast to all the client, you still be able to do it because the RabbitMQ will be is the one that deal with the distributing message, not the process. And oops, ooh, cable. But since we don't have time, but the good news is because nothing is changed from the user, everything's still working the same way. You will see all the message actually being sent like nothing. But on the back end, like I mentioned earlier, the way exchanging message now different. And I supposed to have a demo, but you guys probably need more questions, so I'm not gonna get through all of them. And this is, by the way, if you don't like Tornado framework, which I know that is Facebook is not good at make their code pretty, so kind of hard to hack. So these are the alternatives that you can find. And the last one is actually just if you are being really adventurous, you can write something like a raw TCP connection. That's actually going to be really entertaining. That's all. I'm sorry we don't have much time, but yeah.
All right, thank you. We have 3 minutes for questions if anyone has any questions.
You spoke about Socket.io before. Have you tried Python support for Socket.io? There's a library for the event.
Are you mentioning about this? Oh, now I hear the animation. Are you talking about this guy, Socket.io?
No, I mean, I think it's just G-event Socket.io.
Can you elaborate that? Like, what do you mean by that?
So there's a library. There's a library making use of G-event that is supposed to also provide Socket.io protocol support.
I'm not really sure about that one. Like, I'm sorry. Yeah.
But generally, what would you recommend? Using just WebSocket or using some additional layer that's already made, like Flask Socket.io, for instance?
In my opinion, based on my experience too, I would recommend to actually have the WebSocket as a standalone. Like it should do as little as possible. Like its function is just pass on the message because in most of the like platform that you can implement, like for example, Tornado framework is used like it's called event loop. This is actually a single thread. And when you start, like if one request actually start like like kind of slow, take time to process something, it slow down the whole, like the auto connection. So I kind of try to. So my recommend is keep it simple, keep it small, keep it simple.
Any more questions?
日本語で失礼します。こういう WebSocket のコネクション貼りっぱなし系のサービスってアプリケーションサーバーのリスタートとか、例えば中間装置であるロードバランサーを入れ替えるとかすごい難しいと思うんですけど、普通にやったらユーザーはコネクション切れましたバーンって突然なっちゃうんですごく難しいと思うんですけど、そういうのってうまくどうやったらいいかみたいなアイディアあったりしますか？
So I'm going to try and translate. WebSockets are persistent in terms of connection. So how would you go about restarting instances and processes, managing load balance and stuff without surprising the user? Do you have any remedy for that?
So if the server's down, the load balancer, that kind of thing. I would say usually no, what I have seen is this WebSocket application is kind of it depends on the architecture, but what I have done in the past is have multiple process, and kind of there's a web server that kind of tell which socket to connect to, and for example, if the server go offline or this connection, is usually the client is the one responsible to reconnect it, because the server have no idea who is where's the client. So that's kind of the setup that I'm not sure if I answered the question, but that's kind of the setup that I have been using in the past. Yeah. Sorry. So
Guess that's good.
Yeah. It's not. It's actually there are many ways to actually deploy. Kind of to it's kind of a new technology. They're not my company just also kind of start working on this WebSocket application seriously. So but we kind of start from prototype and then we just use it on production. So that's why we haven't have time to actually look into alternative, in terms of using load balancer. But what I read from the documentation, only in the case of Tornado framework that we use that I use in the demo, if I try to use with Unicorn, which is somehow it's kind of, I think it's dealing with the load balancing, but it's actually this kind of setup is actually disable the WebSocket functionality.
Okay, thank you very much. We're out of time, so that's the end for this talk. Thank you again, Guti, and please give warm hands to Guti.